I was muted. Whoops. Yeah, so as I was saying, hello world. It's been a second, but I'm good to be back. Or feels good to be back. Last time we generated, this is day 166 of studying compilers every day until I land a compiler role. I don't remember what I did last time. Git log. We saved and restored caller saved registers as a whole. So that resolved itself quite nicely. This time we're gonna finish generating calling convention around calls, I think. There's just like one small thing I need to do, which is moving params into the correct function, I guess param registers, and or like pushing extra args onto the stack. So yeah, that should be pretty simple, I think. We just need to keep a mapping. And then after that, we just need to generate the entry point for main, and then we are good to go actually, which is really impressive the more I think about it. It's crazy how I've been able to get all of this across like 150 or so days, plus or minus like 20. Yeah, like 150 or so days of work, which is pretty cool to think about. I'm kind of curious how far we get by day 200. Hopefully we'll be able to generate some good code, maybe benchmark it against some stuff, and then yeah, we'll just have a good time with it. So yeah, all we need to do now is we need to store the parameters in the correct registers. So this will be a little annoying actually. So we need a mapping because we're like saving all the registers, and that's like making a mess. And they all necessarily go into caller saved. So I think this will be fine. Yeah, okay. So we have a mapping somewhere, right? I guess we could make save a mapping, but this feels a little awkward. I see. Let's make a mapping like up here, I guess. So we want like unordered map. So we want map from register star, I think, to our operand, I think, star. Yeah, because we're actually, wait. Right, because all this will be is just an address that we replace it with. So I guess address star. And then we want like saved registers, I guess. I don't know. Or I guess like saved values, I guess. I don't know. We'll call it something like that for now. Okay. So we do all this stuff. We do all that. Oh, this actually should go later, actually. So this goes here, actually. So we have the stack slot. Actually, is there a better way to do this? I feel like we could avoid saving this mapping and just one-shot this, actually. We could make like a list of instructions somewhere. Yeah, this is awkward. I guess we could think about this in terms of what we need first. So we could start here. So each arg in, yeah, so we can do arg in, or we want, so we have the call, and then we want get args, I think. We have get args somewhere, right? Oh, we should definitely do that. Oh well, this is fine. We could probably make this more efficient, but I think it's fine. We can just call it chill there. Yeah, we can get rid of this comment as well. And this is a vector, right? Yeah, it's a vector. Okay. So, I guess we could just save stuff and do something, question mark. I guess we could just restore them here, just in order maybe, and then if it's in saved values we use it. Actually we could just save the value from the register instead of like caring about saving it actually. Huh, wait. Yeah, I'm not sure what the fastest way to do this is. We could try it this way for now, and then we'll see if we can optimize it, I guess, for the rest of the stream. Let's just do it the lazy way. Yeah, so we have this push. So we're pushing reg onto the stack slot, so I guess we could do save values at reg. That should equal stack slot. Yeah, so we can just do that for now, and then we can map this. So what we want to check. So arg can be a bunch of different things. We want to check if it's a register first and foremost. So if it's a register, and if it's a register, we should get the value that we put on the stack slot, I think. But we're using like the full size reg, right? Yeah, that makes a mess. Yeah, this sucks. I guess we could just move the thing into the full size register anyway. It doesn't particularly matter. Yeah, this is awkward actually. What order are these in? These are in like, these should be in the correct order. So then we can just, I guess we can just loop over it. And then, yeah, we need to like loop over two lists in a way. So we can get like, let's do arg reges equals, we want get arg registers. So we want that. What's good, Smokey? What are we building here? I'm making a compiler from C to x86-64. And I'm like recreating a lot of LLVM's like infrastructure from scratch, for instance. So yeah, it's been a good time so far. I foresee it not changing insofar as how good of a time it is in the future. It should be a good time all around, just in general. Yeah, so we get the args. Also, like, let me know if none of that made sense. I assume that you have like some degree of a computer science background. Okay, what do we even how do I want to loop over this? I guess we could do like arg reg index. We could do that maybe. So then we can loop over this, and then actually wait, no, we should loop over it the other way, right? We should, yeah, wait. Yeah, okay. So then, yeah, let's change what we loop over. So we could size ti equals 0, or I don't know. We're not really consistent with naming, but I'd like to fix that at some point. We have like, yeah, we have num params, so I want to reuse that. Although I think if we already care about num params, I think we can just reuse wherever that is. Yeah, so it's here. Do we loop over things? I guess not, huh? Okay, well, that's fine. I've been wanting to get into compilers. I'll revisit your early streams. Sounds good. when I started this stuff, I already had like some degree of infrastructure built out. It was mostly the front end, so it wasn't anything particularly interesting. I think all of the middle end stuff was pretty interesting, and I think there's more of it that I'll be working on in the coming future. So stay tuned for that at least. If you want like concrete resources to get into compilers, let's see if Nightbot is awake. If Nightbot is awake, I won't look like a fool for typing that in chat. Okay, let's get rid of this. This should be, yeah, num-primes is fine. Oh, we should steal some stuff. Okay, well Nightbot is obviously making me look like a clown. Let me make sure Nightbot is up. Nightbot's supposed to be up. Commands? Hello? Wait. Am I tripping? Yeah, let's try that again. Come on, Nightbot, please? Nightbot? Come on, Nightbot, please. Okay, well, exclamation point Rex in chat should... it should have a neat little recommendations. So like... yeah, so if we do like Rex, like, yeah, there we go. Hopefully that works. If it doesn't, then like, I don't know, I'm gonna need to fire Nightbot or something. That's really annoying. Okay, well, I will figure out how to fix that, but let me just paste the little pile. Alright, let's see if this, surely that went through. Okay, I did. That is the recommendations. Do you think programmers need leet code or code forces, and without them they will never get to the higher stage? It's complicated. I think I think on one hand, they don't necessarily correlate very well with like actual programming needs. On the other hand, I think it's important to, I guess like just pragmatically speaking, you will need to get good at solving those sorts of interview questions just for like the interview, which it sucks, but like that's kind of how it goes. Like every other, like all of the other large professions have like some sort of a large exam if you need like some sort of accreditation. So I guess this is kind of the best we can do, unfortunately. Okay, so we want, so val equal, or I guess pram or arg, I guess. Let's keep, oh, what do we call this? I guess we can just do param, and then we need to yoink that stuff above again. Okay, so we want this. We want this ternary thing. But we want something different in it. So if it's greater than 6, then we want, I guess the other case is easier to handle. We can just do arg reges at num, or, oh, this is annoying. Instead of num params, let's do index. Yeah, so we can do that, and then, or we want om get register with that arg. Yeah, so arg reges stores like this register num type, which I guess just to show in case y'all haven't been around. The way I represent registers, so this lives in operand. So there's like immediates, there's like addresses, all sorts of registers. There's like the stack arg thing we already got rid of at an earlier point. The big thing is like this register type. So it has like this register enum value, and then it has like an ID. The ID is just for like sorting reasons, but the enum is all in here. So it's like all the 64-bit, all the 32-bit x86 registers. It's not anything complex, but the big thing is that this is distinct from the actual register type, because the register type, I guess, is also a base class for this virtual register thing, and that's a base class for this constrained register thing. It's a whole mess, and I kind of wish I designed it differently, but this is the pile that I have to work with. So we have this operand manager, which manages like the actual operand values, because those are unique pointers and I want to reuse as many of them as possible. So that lives like that. And get register takes a register num, and it returns like an actual register pointer. So this is how we're doing that. Do you think a beginner can start with code forces? I think you can. I mean, yeah, I guess that's kind of how everyone starts. Like, you're not expected to like know everything, at least. So I don't really think it would be fair otherwise. Like, I mean, there's no better way to get started than to just go into the deep end, I think. And that's just software. Okay, so this makes a mess, actually. Yeah, how do we do this with a ternary operator that's not ugly? Yeah, so we want to get an address, which is so annoying. So we need to like steal stuff from above here. Yeah, so we need like this awkward thing. So we want this get address. RSP is fine. We just need the immediate at. Oh no. How do we, what? Oh, I see. So saving goes from, I guess, end to front. So this is going the other way. So front to end, I guess, which makes sense. So we want this closer to the top of the stack, I guess. So this should just be index -6. We need to surround that with more parentheses. So you do that, and then times 8, I believe. Do we do that math somewhere else as well? Yeah, we do it like here. So we do something like that. Yeah, so let's reformat all of that. And this is not actually the ugliest code I've written. So we take those, I guess. That's a neat surprise. Yeah. Okay, so we have that. What type is this? Oh. So we want, or we might have to static cast this to operand. Which is ugly, but it's fine. Actually, we could just static cast one of them, huh? What if we just static cast the other one? Right? Does that work? Oh, that does work. Nice. Okay, well, it's just gonna look ugly regardless, which is fine. Yeah, we will cope. Okay, so we have the parameter. So that's like the destination operand for this. And then the source, we just need to figure out how we're ordering this. Okay, so then, so I guess val reg. So we want to dynamic, or we want val first. So we want arg, or we want get args from call. So I guess auto arg vals. So that should be get args from that. What type is this? This is a ref, so we could probably do that, actually. This can't be a ref though, right? No, that can? Okay, that's odd. Oh, wait, no, this definitely can be. Wait. Let's... I have some changes I need to make here. Yeah, so this should be a ref as well. We're just doing a little cleanup work real quick. Okay, I think it's all cleaned up. Yeah, okay. So we're still working on this little thing. So arg vals at index. And then, so what do we want to do with this? What type is this again? This is a val, this is an operand. Oh, so we need to check if it's a register, because if it is a register, then specifically if it's a caller saved register, it might have already been like pushed onto the stack somewhere. So we need to do something about that at least. Yeah, and that might make some sort of a mess. So we need to, I guess we could restore it from the stack. Yeah, that might be the play. That's right now why we're just saving everything. It's not like optimal. There's probably a cleaner way to do this, but this is kind of all I can think of for now. So we kind of just have to do that, unfortunately. The more I think about it, the less able I am, I think, to directly clean this up other than doing it like this. This is at least the easy way to do it. So we want to dynamic cast it. If I can type. Give it val. If val reg. Then val equals. Alright, so if that exists and arg reges has it. Or wait. Not arg reges. Saved values, I guess. If it has val reg. Yeah, so we can just do that, I believe. And that's fine. So that just replaces it if it's something that was moved to the stack. So then we just need to generate a move. So I know we generated moves up here. So let's just yoink this real quick. So then let's MOV. So we want to move from val reg or val to param. And then we want to insert it before, so we want to copy this line. So that iter, we want to move MOV. Yeah, so that should work as intended. It's a little bit ugly, but it'll do. So let's make build, and then we can make tests, and let's see how everything looks. Hopefully it all came out kind of alright. This should fail some tests if we did it correctly. So that's not how it's supposed to fail, which is not good. Where is this going wrong? Alright, let's do params. Okay, let's val grind this. Why is it taking so long? Ah, here we are. Yeah, okay. So this is the only pass we've changed so far. This is in 240. It's here. Oh, wait. This bracket operator. That doesn't make sense. Wait, what? So argregs is, so what type is this? I guess we can look at what argregs was again. Yeah, so let's look here. Yeah, so we should have, this should be fine because we're going through the correct indices. This should not be out of bounds. This really should not be. Yeah, this doesn't make sense to me. I'm quite confused. It's at 240. Okay. Yeah, so we're getting this correctly, I think. So we have get arg registers. Maybe it's because it's a ref, but I don't think it is. That should be fine. Maybe I should return this as a ref. Like that? Oh yeah, that's not gonna, okay, yeah. This should be good though, I'm confused. Okay, what is failing specifically? Okay, it's the bracket operator. So what is index? So if it's greater than 6. Oh wait, we should swap these because 6 is the cutoff. Yeah, so let's swap those around, and this should also have the benefit of making this look prettier as well. Okay, well, this is still ugly. Let's move the static cast to the other one instead. Let's do that instead. Let's get rid of that. Oh god. What happened? Oh, semicolon. Oh, semicolon. There we go. That's a little bit prettier, not by a lot. This is heinous, but we will make do. Okay, make build, and then we can make tests again, and that should be good now. Actually, yeah, so that doesn't crash anymore. Let's make test. This should fail some. There we go. This fails all the ones with params, I think, which makes sense. Although I think we have params in another one, so I'm not sure what's happening to those. I guess they don't get put onto the stack, or we don't call them anywhere. Let's regen the regression tests just to be safe. So let's see. Yeah. So here for instance, we're like doing all this stuff. Yeah. Okay. So doing all this moving. These all come before the function, which is good. This one matters because I think we swapped the order. I'm not sure though. Regardless, this is important. We could probably do some sort of like better way of doing this without generating as many moves, but I think that's probably like a later problem. I'm not particularly concerned about it right now. This is the interesting one because this is giant. So RDI, RS, these are the correct order, and then we store onto RSP and then the next stack slot, which is good. Yeah, this also avoids like the whole register size issue, which got really annoying. So this should be all pretty good actually. I think we've generated all relevant calling convention. Like this looks solid. Yeah, and then the immediates are already done, which is also cool. Yeah, how do we want to? Let's think about this. We could probably generate better code by like keeping another mapping somewhere. I think we could probably do that real quick. We can just do a straight up copy unless we've like copied to that register already. Yeah, so we care about it from val at least. So yeah, this is gonna get messy. This is gonna get really messy really quickly. Yeah, do we want to regenerate it? Like, Okay, I'm lazy, so I think I'm just gonna keep it like this, and ambitiously, let's see if we can get code that like actually runs by the end of today. So this is done. The only thing left is generating the entry point for main. So that makes a bit of a mess. We need like some sort of preamble stuff, I think. How do we do this? Yeah, so I like looked this up before. I didn't really know what to do with this. It's like start. Yeah, okay, so we should do like that, I guess. Or maybe this was useful, right? I guess the other way we could do this is we could look at Clang and see what it does. So I think we did this in here. Yeah, wait, what? And WSL is struggling. Okay. Wait. Yeah, okay. So I have these like directives at the top. So I guess we should look up like the GNU assembler or linker. Oh, GCC linker. Yeah, we could LD. That's what we care about. Oh god, that's bright. 1 second. There we go. Okay. So we just have entry, I guess. That makes sense. Table of contents. This might be useful. Invocation. Okay, that's a lot of flags. We don't care about a lot of these actually. Let's elf program headers. This is linker scripts. This is fun. Is there like a good entry point thing somewhere? Maybe. I guess we don't care about command language. Overview? I think the linker comes before the assembler, right? Am I insane for that? Wait. Do I know this? I feel like I should know. Assembler first. God damn it. Okay. Okay, let's look up everything in here. Yeah, okay, let's look at the table of contents. Input files, maybe that'll be useful. Syntax. Yeah, this is not helpful. Okay, something about white space, removes comments, character constants, sure. Include file processing. Something about white space, comments. Oh, this works. Right? Wait. Wait, what? Oh, wait, it doesn't matter because we're not keeping comments around, so I guess that's fine. Something about symbols, statements. Sure, a lot of stuff. Okay, none of this is helpful. How do we even make this useful? Directives, I guess? Wait. Let's ask ChatGPT and make sure I don't leak anything. Okay. How do I generate assembly, x86, 64 assembly for gas? I mean by hand. For my personal compiler. Specifically, yeah, we could just do that. Yeah, so we want a format. That is what we want. We hear about this ABI, something about AT&T syntax. We do AT&T because we're lazy. Oh, interesting. Okay. So we want something like this. Alright. Okay, so we want... Wait, what? Yeah, that's all we do. This makes sense. Data section seems annoying. This is fine. We already do that. Intel would be smart, but I am silly, so I am in fact not. Ooh, I got into a class that I wanted. Yippee. Okay, I got into one of the classes I wanted. Let's go. Okay, anyway. Yeah, I should have been doing Intel. That would have been smart. Oh well. Oh wait, local label starting with .l? That's cool. AT&T, Linux, elf, only, yes, calls. I just need to figure out how to represent functions and an entry point now. Perfect. Yeah, sure. Thank you. Wonderful. Okay, so start. Okay. Okay, so this is what we want to do. So we want start that like calls main at least. Yeah, maybe we could also, it might just be easier if we look at this slush pile. So let's do like int foo, I guess a, or int a, int b, return a plus b. times 5 or something as an example. And then here we want like more substance. So we want like int first, or we could do like one, or I don't know. Let's do like x equals some number. Do that, return foo of x, y. And then let's do this again. And then we can look at this. And this will be more interesting. Okay, so I see a lot of the .else, which is interesting. I should probably generate that real quick, actually, in my printing. Or when I make labels, actually. I think I have something that was like make label. Or is it in like, where was this? God damn it. Backend, LAR. Right, no, it was in the LAR tree because this was instruction selection. I think it was in tree generation. Label. Ah, resolve label. That's where it was. Yeah, so it's here. We do dot name. Instead, let's do dot L. Wait. Okay, let's commit this stuff real quick. Here we finish, or we move params into registers before calling function, or before call, I guess. Or I guess args into registers, or args into slots. Values into args. There we go. Make build, guild build. Let's do that. Oh, what is wrong here? What? Oh. Okay, let's try that again. Except this time we do this correctly. Let's replace this with .l. Let's try that again. How's everyone's day in the meantime? Hopefully everyone's doing alright. Okay, this breaks everything, which makes sense. So it's like, yeah, so these are like blue now, which is good. That's what we want. Okay, so we have that. That's good. So it's just one thing? Okay, nice. Oh, add L to dot label. Okay, cool. So that's that little change made. I was wondering why the assembly looked weird. I guess that's my answer. So now we get to worry about this. I'm a little scared. So I guess we could look at what Clang does. I guess we could also look at GCC as well. And then we could do test.c-s Aye. We move that to gcc.s. So let's compare these. Oh, there's like a line. I see. Okay. Well, this is interesting. Huh. What is this like start proc thing? This is confusing. So clang is on the right for reference. Oh, this also has like end as well, which is interesting. I guess both of these. Wait, what? Oh, I see. That's interesting. So here to that. Okay, yeah. So you have these things, and then yeah. So we have this like end proc thing, I think, which makes sense. So where's the entry point generated? That's my question. What does ChatGPT say? I'm very confused. Right. Yeah, this doesn't... I'm not understanding a lot, to be honest. So I guess this .file thing we can always include. That seems simple enough. Or we could just not do that, alternatively. So I guess we want to mark .text regardless. And I think these two are like basically mandatory. So .text at the top. Wait, I'm so confused. So where is the entry? Or I guess maybe as long as it's just named main, it's fine? I don't know. This is... I don't understand. But that's fine. We can work with this at least. So we need to go back to regalloc proper... Or not regalloc, codegen. So for each function, so we generate the function label. I think we need to generate the preamble for that as well. So this, we go back here. Let's look at like the GCC one. I think this is simpler. I guess we could call this preamble, right? Just generically. Yeah, because we add this as well. We can rename that actually. And then we also need to rename it here. That's good. That's good. Okay. So we want like... I guess we want the global and like the... Wait, what? Oh, we just want the global and the type. And then at the end we want size, I think, right? I don't understand these directives very well. So if anyone does know what is happening here, I would like to... It would be nice if I got an explanation, but... Yeah, we're just gonna yoink this. So we can do that. Is this a tab? Oh, that's a tab. Oh, okay. Well, that's annoying. Let's make this simpler. Okay. let's do name. Let me do that, like that. So we can do that. And then here we want type. It should be type. And this should be 2 spaces. This should be 3, I think. Wait, what? Oh, I see. Okay, there's one offset there, which is fair. Set main, comma at function new line. Oh, help, yuck. Okay, so that's good. And how is the size thing determined? So dot to, or dot minus a label, I see. Okay, well that's reasonable enough. Yeah, okay, we could do it like that. What is this like start proc, end proc stuff as well? I don't understand this very well. Anyone get it? And what is... I'm so lost. So we can do this. Alright, so we want to do this, and we want to plus equals... This is dizzying. Yeah, so we can do that. Actually, we could just do result plus equals. Yeah, this might be easier. Wait, what? What am I doing here? So it's empty, then we just do a list. Oh, I see, because we might need a new line. Okay, here's where we should move that to the top, actually. Let's actually, what if we just... That's so annoying. I guess we could include that in the postamble, actually. So we can clean that up, actually. Yeah, so we can do it like that. And then we'll figure out postamble in a second. Okay, so we have like this stuff done. We should probably add like... We should add like starting preamble, maybe. And then we want to copy this, but as like postamble. Yeah. We're making a mess. Oh lord. Let's do that. There we go. So I don't need that anymore in there. But here I think we should add the if check. So if it's empty, then... Or if it's not empty. Because we also want to account for like last instruction. We don't want an extra new line at the bottom. Let's do that. Yeah, okay. So now we need to figure out the postamble. So we can do that again. This sucks. Yeah, so we could do that maybe. I don't Oh, wait. Wait. Wait, so what happens if wait. I have an idea. So let's just give Cling call chain S, or what happens if we do that? Oh, that doesn't work. Huh, okay, well. That like almost worked somehow. So I guess I'm doing addresses wrong then, which makes enough sense. Huh. Yeah, this is the wrong size. Ah, okay. Well, maybe I worry about that later. This might be a later issue. We could say that we just gave this a start. I don't really want to do a lot of this right now. Let me look up the slides from the class that I did take like 2 years ago. I think, because there was like a very simple or simplified way of doing this that I don't remember, but it worked for us, so presumably this will make things easier. Yeah, so I guess we could look through this slide deck. So, AT&T, This is what we need to do. Yeah, so this is like not quite, this is like not quite assembly, but it's kind of like assembly. So this is like what we needed. So we need, oh, I see, okay. That makes sense. So then we have this runtime file. I guess that makes sense on how we did that. But this is not what I want to do. I'd like to do it differently. Maybe I do it the hard way. That might be funny. So where are these offset things? Yeah, this is rough. So what is CFI again? Let's just ask chat. I'll just give it all that. Okay, so this is like, I guess .text is what we want to start with, at least regardless. So then file preamble, I guess we could call it that. Okay, so this will never be empty then, so we could actually just start with that. So we want to add, so we want .file, or we don't care about file actually, we just care about .text. Yeah. And then we want to yoink that. There we go. So we can put that there, that's good. So then we want to generate file or wait, what? Oh, that works. Okay, nice. What else do we need? So this makes sense. I guess this align is fine. I don't think we need to do that. We need this as a function in elf. That makes sense. Okay. So we generate the global, we generate this, which is fine. And then I'm lazy to do that, so I will not do that. Oh, what is call frame info? I see. Okay, so we can ignore that. Nice. Sounds good to me. Okay, all that's normal. Oh, this is a very clean way of explaining things, actually. I should steal that for my own projects. Or for my own explanations, maybe in the future. There's a chance I will make a compiler's course in the future. No promises, but that would be something I want to do in the future. We don't care about the body. Epilogue, okay. Pop, ret. And then we have this thing. Do we need that? Let's do that. Okay, so then this is fine. I guess we could just leave that as that, and that's good enough. Leave? Leave? Yeah, that makes sense. Yeah, okay, this makes sense. I should do ret q. I don't know why I'm doing ret. Okay, so we need like this stuff, right? Okay, so I guess we don't really need to do this then for now. We could be lazy. Yeah, so we don't care about that. We should probably do this, but whatever. So let's compare these again. So size, we have nproc. So this ident. Let's do ident because it's funny. Because then we can say panic in it and it's really funny. Section, I think we can yoink as well. Okay, we don't care about that. Yeah, let's do the identifier because that's funny. And then we can see if some poor schmuck has written something with or compiled something with panic for some reason. Or ident. And this is 2 spaces. Nice. Yeah, we can do that, I guess. I guess we could put the GitHub URL, whatever. Let's do a little self-advertising. I don't think this will ever come up, but like let's do that anyway, just for fun. Hopefully y'all are enjoying this as much as I am. Okay, and then we should do section, I think, right? Yeah, we should do section. Yeah, let's steal that because that has prettier colors. Have to watch Dr. Jonas Birch videos? I do not know who that is. Let me look him up. Oh. Okay, that's a lot of C stuff. That could be fun. I also see a bunch of like security stuff, which could also be interesting. Yeah, I'll give his stuff a check out. Thanks for letting me know that he exists. Let's yoink all that. Let's stick that there. Yeah, so there we go. That's good. Postamble. There we go. That's good, Link. Good to see you. Oh, I'll probably still give his stuff a little bit of a check anyway, just because why not? These need to be escaped. There we go. Postamble. So what happens if this works? Hour late? Nah, you good. I also started today a little bit late, so it is what it is. Okay, so now we're just like trying to see if we could get all of this to work, which is very interesting. Attempt at getting rest of pre-post-amble done. Wait, so let's try like build bin panic test regression input. Let's give it call chain C. And let's do that. Oh, wait. I did something wrong. Oh, I forgot to add a new line. Oh, okay, I understand. Okay, so let's look at this file. So this stuff at the top looks good. Something is wrong with these. I think I need an end label as well that I'm missing. So let's go to let's go back here. Oh, we actually need to put stuff in the function postamble. Or at least one thing. Let's add a label there at least, I think. We could do end like that, maybe. How does Clang do this again? Or GCC? Oh, we could do it with like a .l again. That's cool. Do that. Yeah, we can do it like that. That makes sense. Been having a lot of fun relearning Zig. Ooh. What features specifically are you enjoying with it? Projects to making it? I mean, you could do anything. The world is your oyster. I think the two you've listed seem pretty solid. So much Zig and enjoyment. Makes me happy. Where am I? There we go. I will stick to my little Rust programs, for better or for worse. We rebuilt, right? I hope we rebuilt. Yeah, okay. So we have the end label now. So we have all of that stuff, that's fine. Oh, we didn't include a new line there. Okay. For this postamble. Okay, well that cleans things up a little bit. How do you learn C? I start Python as a beginner. That's fair. I started with just like our school's like intro sequence class. We had like a class that was C++ and C, so I took that, and that was like perfectly serviceable. Obviously that's a little hard to reproduce, so I don't really have a great recommendation, but I'm sure someone else in chat probably will have something good. Some safety checks like leak detection, out of bounds. Ooh, that seems nice. It feels like Rust is more to like C++, or Rust is to C++ as like Zig is to C. I think that's a little bit more of an accurate, I guess, or like the characterization that I think makes sense in my head. Let's add a new line. Those have new lines, those have new lines. Zig has a lot of nice meta programming features. Ooh. I feel like every time I try to do meta programming in any language, it's just a pain. Even like Rust is a little annoying. Okay, this looks better. This looks a lot better. So what happens if what if I do clang now? Oh, that needs to be a string. Whoops. Okay. And let's escape that character. Oh, that looks way nicer in Zig. Yeah, that definitely feels less miserable than the average experience elsewhere. Okay, let's keep running this. Okay, let's try that. Okay, so we just need to fix the way we format things, which I guess makes sense. These should not have the $sign, I think. Okay, there we go. We need to format. Whoops. Oh, really? Okay. There we go. Okay, so the last thing we need to do is fix like our address to string, but I'm a little lazy, so I kind of don't want to do that right now. I might do that later. Just out of curiosity, can I just like replace these? Just $. Let's do a find replace. Let's do 1, 2, 13 substitutions. So this should be good, I hope. Fuck, because these types are wrong because I messed up somewhere. Okay, let's keep editing this until this works, because I want to see if this actually generates. So everything's in here that's wrong, I think, right? What is wrong with this? I don't... Oh. Are these all before calls? Oh, these are save and restore. 75. Yeah, okay. So it's all save and restore stuff. Yeah, that makes sense. Being able to manipulate type directly lets you do a lot of stuff conveniently. I see. Yeah, I think the big thing I wish that like C++ had is like better pattern matching. Ignoring the whole package manager issue, there's like a lot of like just general like matching that I wish it could do better. I guess like that's kind of this whole Zig metaprogramming thing is kind of an example where like it really does irritate me. But yeah. How are you testing your compiler right now? I don't have like, I don't really have any like positive tests, I guess. It's all regression testing. So this is kind of awkward. I don't have a great way of testing, which is a really big problem. I guess, yeah, I might have to like rewrite some of my testing just to, whatchamacallit, just to have like actual like runnable benchmarks. And then that's nice because then I can test it against like GCC and Clang, which will be fun. Yeah, so we need to fix some stuff here. So the first thing we need to fix is the immediate in addressing. You have something to check that your parse is correct? Hell no. I don't have like unit tests or anything. It's just like we just check against the previous output and see what changed. Yeah, so that's not ideal. I would like to do something better, but for now this is kind of the situation we're in. Let's get Scottish. Won't be here long, but I've been doing arrays in C++. Yeah, it's like the same concept. The big thing is like I think they're fixed length. Or arrays are like generally considered the fixed length object. I'm not sure how they are in JavaScript, but yeah, I mean they're contiguous. They store a bunch of values. They're quite nice. Everyone likes arrays. If someone doesn't like arrays, they don't know their history, I think. Okay, let's make hell. Operand. So this is an operand. Let's open the header on this side. We care about address. So we have the toString for address. So instead of get or what? Oh wait. Get value. We want toString with that. I think we need the same for scale as well. Yeah, we do that already, which is nice. Let's see if this builds. Something I want to test at some point in the future is I want to try doing like fuzzing. Maybe not writing my own fuzzer. That seems like a really far call, but at least like using one of the well-established fuzzers. So like we tried doing this for one of the classes I was in, just like this past week, and it was like a lot of fun. Like we brought like CLI programs. We did like some fuzzing. It was fun. I kind of want to do that here because there's actually a lot of bugs that simple activity in class caught. So I want to get that set up at some point. I was thinking like what was it called? Where am I? Yeah, I was looking at Redamsa. I think that's how it's pronounced. It's in GitLab. Yeah, this is like, I think this is the generic one that people like a lot. So I might try that. In JS, you can change the amount of items in an array using push. Yeah, so that's like, there are like some small differences here and there, but it's all like kind of working the same. If you're familiar with like that push and pop sort of thing in like JavaScript, instead of an array in C++, you want to use a vector. You've probably seen me use vector a lot, so yeah. That would be the closest equivalent. But yeah, Redamsa. We love Redamsa. This is great. I don't really know how to do like pattern-based fuzzing, so that could be fun. Something else I was looking at actually. This reminds me. So it turns out the prof in that class. This is like a class about like software, like responsible software engineering. There's like we study a bunch of like tech failures. Something that he introduced me to was CSmith. Yeah. So this literally generates random C programs. So this could be fun. And then I think you can specify. We can specify a bunch of stuff in here. This is going to be like the really fun thing to mess around with. So, yeah, I'm quite excited. to maybe integrate some of these. It's gonna be fun. Yeah, it apparently has found a bug in every major like production compiler, so, or every major production C compiler, which I think is really cool. This is this is pretty funny. But yeah, I'm gonna probably mess around with this at some point. It might be fun. It's like kind of random testing, which I think is probably strategic. We'll have to see what reproducibility looks like for it. Anyway, we want to let's run call chain. Let's look at call chain again. Now I want to write a C compiler. Yeah, I mean, always happy to have more people join me here. Okay, these look correct now. We need to fix the sizes in a second. Let's clang this real quick. We just don't have valid operands for these, which is fine. We'll change that. Writing tests for your own language is more work? Yeah, exactly. That's like also part of why I wanted to do C. Because like even if the compiler is hell, like I'm gonna need practice for that anyway, because we don't write easy toy languages to work with in like large, or like from like a general like usability / pragmatics perspective. And B, it's also like, I don't want to write like programs and tests by hand. Like I was considering doing brainfuck because like it's an easy language to like compile, but I don't want to write tests in that. So like, I don't want to do that. It's just a rough experience. So yeah, it's always fun working with a very well-defined spec, at least. Okay, so we need to modify code or legalize. Specifically, this is storing. Yeah, so we changed the size, which is annoying. Let's make this double word for a second. Register size, or what was it called? Reg size, god damn it. There we go. Let's see if this works now. Hopefully this works. Okay, let's do that. God damn it. Okay. Well, we have to change some things, which fair enough. Okay. Let's not do this the lazy way. So let's fix those two things down there. Where did I put that? Here we are. Reg size. There we go, like that. That's good. That's happy. That's excellent. W3 schools is good to use to learn. I think it's all right. I've heard a lot of people say that like it has incorrect info sometimes, so I'm a little bit hesitant to trust it, but yeah. That's kind of my take, at least. Okay, so we want to change what's it called, liveness. We want this to just use fixed register sizes instead of dealing with this shenanigans. But maybe I do that next time. I don't know. This seems a little annoying right now. Let's update check operand, actually. Let's replace. Actually, do we check liveness for this? I think not, right? In coloring. Do we do like a get size on this thing? So we don't care about that case. What is flat size again? Where did this come from? It's quad word, okay. Oh yeah, so we literally just get the size from the register, okay. Yeah. So we literally do not care about this. So we should just replace this and see if it breaks anything. It will break something, but okay. So let's let's do data size quad word. Should do that. And then if reg, we want, oh boy. This is awful. So we want, oh no. So we also need to distinguish virtual and physical registers now. If you can test if someone's telling the truth or not. I mean that's true, but also I expect my like learning materials to be accurate, right? I don't know. Maybe that's just me, but yeah. Anyways, 2:30. You should probably get some sleep. Take care. Thanks for stopping by. Okay, so we want this to be virtual register. Yeah, so we're not just directly inserting the registers. So we need to like do some resizing. So we want get register. Let's give it get name or wait. Or not oh. Virtual reg. Get name. And then, or actually no, we don't even need virtual reg. We can start with register. So if reg exists, so we want reg num, so we want reg get reg num, and we want to size it anyway. So we want to sized, we give it that, and then we give it quad word. So then if reg num is so it's virtual, and we need to do something different. Yeah, we can, I'll clean this up in a second. Yeah, so we can give it that actually. Or maybe we could give it this entire thing actually. Aye. So we want reg get reg num like that instead. Yeah, so we can do it like that. So then, oh, we could use a really unreadable ternary operator. Let's do this. So we want if reg num equals, let's just yank that. Let's paste that. If that, then oh no. Oh yeah, because they need different parameter types, so we can't actually like deduplicate a little. This is fine. So we get register. This takes reg get. Oh, we need a static cast. Oh no. Okay, this is just gonna be a really long one-liner. This is gonna be great. So let's give it reg. So we have that. And then get name. What am I doing with my life? This is so dumb. I think we had like a size defined in here as well. Flat size, yeah. So this is where that lives. So let's actually move this from interference to liveness real quick. Yeah, so we can do that instead. Yeah, let's do that, and then we can also like, we can reuse that in some other places. Yeah, this is actually like abhorrent code. I don't know why I'm doing it like this. So we can do that. Otherwise, let's do get register with this thing. Yeah, so we want LR to size that. Oh, wait. Paste like that? Nice. So format, and that's all ugly, but that's fine. There we go. What's the Lunar? Yep, sorry for taking a second. What to recommend for learning C++ as a complete coding beginner? I don't have a great resource for that, to be honest. I think Python might be a better introduction to just programming in general if you haven't written any code whatsoever. I'm sure someone else in chat will have a better recommendation, but I don't have a great advocacy, at least. Okay, yeah. So this code is so ugly, but it's fine. Okay, so we've done some sizing. Do we need to do this thing again? I really hope I don't need to do this again. I should just do check operand. Yeah, it is actually pretty readable like this, surprisingly. So what the hell do we want to? What do you want to do with this? Go look on your journey to landing a compiler rule, compiler code. Sure. Thank you. That does mean a lot. I appreciate your support. I guess we could recursively call check operand, but I don't really want to do that because we'll just step through the constraint. Actually, there's a world. I guess we could do this thing again. I really don't want to duplicate that. So I guess we could just chuck operand base. I can do that and call it a day. Yeah, let's just do that. And I don't think this should break a lot of things. I really hope this doesn't break anything. Yeah, this would really suck if it broke a lot of things, so. This will, okay, that does break some things actually. And regalloc is running forever. Okay, I see. Okay, so that means we can also simplify some things in other places. So legalize, we don't need this reg size thing anymore. This should be flat size? Yeah, we can do that now. Ah, so much better. Yep, still going. There we go. Perfect. Okay, so then, oh boy. We've just made a mess. So, liveness affects interference. Yes, this affects how this is done, I believe. Okay, we don't need flatten register anymore because I believe it's already flattened, at least if we're given. Wait. What do we need F for here? Wait, do we just not need the function? Wait, what? Why was I passing it the function? Wait, what? Wait, so did I just not need that? Oh, okay, guess I didn't. That's pretty neat, actually. That's pretty funny. Okay, sure. I guess it's all encoded in liveness, so that's fine. Okay, so this interference is fine. So we just need to change interfere now, I believe. We don't need flatten register anymore, because it's already flattened. Wait. Yes, we can just do that. Yes, we've already done this, I think. Yeah, so we just swap, sort of. Yeah, this should also just run faster, because I think we do interference more. Or wait, no. It's probably not faster, but like every time we compute one, we should compute the other anyway. So this is like fine. This should be reg. Yeah, that's good. We don't have, oh, we have flatten here. We don't need that anymore. Yeah, so we don't need this anymore, I believe. We just call this, oh, virtual reg. This is annoying. Oh, wait, no, this we do need to flatten. This we do need to flatten, because this compares against the actual thing. This is already the right size. Yeah, so we can do that. Or wait. No, this one we need to flatten again. Yeah, okay, so I think all of these we do just need to flatten. Let's see if this all works now, though. This shouldn't infinite anymore, at least, if we did it correctly. Oh, we need to change the way we call it. This is in regalloc. We don't need F here. Let's do that. Oh, many were just, oh wait, there's a problem with spilling. Ah. God damn it. Okay, this is annoying. This is so annoying. Where did we do this? Wait, what? Oh. So we don't use interference anymore. Do we need to flatten? What am I doing here? If you want to write classes that traverse the AST, would you provide a default impl? I'm not sure. I think it's all very like case by case, at least. I don't think I can really like concretely say anything. But yeah. I think I need to like see a specific instance to probably say more. So what am I doing here? Oh god. What did this code do? What actually did this code do? Oh, I see. I see what's happening. Okay. So we have virtual register. This takes dest. So we need to size that correctly. I see. This is all fine. Need to change this. We don't need to flatten anymore for these, because this is in the gen set. Right? Ah. What the hell? Okay, so we don't need to flatten these either. Wonderful to do? Yeah, that's how it is. Hopefully you're doing alright, Aiden. I imagine there's some work to be done. Okay, it still hangs on this test. This is a different test that's hanging on. Why is it on call chain? Wait, what? Okay, wait, there's so much refactoring work to be done because I made a poor decision early on. Okay. So this should flatten let's maybe print some stuff actually. Not gonna do that? Fair enough. Let's give it F liveness. Alright, let's see what call chain does. Yeah, let's just... Let's do that. Wait, let's see. That's not supposed to happen. Something seems wrong. I can't tell what's wrong. Something seems very wrong. So we're just looping through this infinitely. So let's print something else. So I guess it's just not spilling. Maybe our spill costs are different actually, now that I think about it. Or we just have to like look through every pass one by one, which sucks, but oh well. Get restricted registers. Oh boy. Okay, so you have the gen set. This to-do is very accurate actually. What in the world is this? So this we need to flatten. God damn it. What the fuck was I doing here? So this is for each instruction. We check if it's a move. Why are we checking? Oh, I see. So if it's a move from a address to a register, or specifically a physical register, then we skip. So then we turn it into a virtual register. So then we need to flatten that. Yes, okay, this makes sense. Yeah, okay. Oh my god. And then what the fuck was I doing here? Where is not load only used? That's the only place? Wait, what? Oh. Okay, I'm definitely doing something wrong here. This is the nightmare of spaghetti code. This is awful. Okay, we need to figure out this like not load only thing, I think. Yeah, we'll figure out correctness later. This is kind of just like an optimization thing at least. This is what? Just oh wait. Yeah. Yeah, we need to do something with that, presumably. I definitely do something wrong there. Okay, let's look at this again. So we get that. Oh, wait. Okay, so we're looping through these, so these should be flat. These should be good. So then spill is probably wrong. Why is size double word again? Oh, I see. Oh. Okay, we don't need to check some of this now, I think. So we don't... These don't contain reg 32 anymore. But these contain 64, I see. Okay. That is the complication. Right? Ah, what the fuck? Oh my god. I'm going to implode. This is why we needed the size. This is so dumb. Oh my god. Okay, none of this makes sense. Let's resolve this next time. Let's restore everything. Okay, let's just push. We're really close to done anyway, so I understand why I made that decision now. Hopefully next time we will have enough time to get this all sorted out. But if not, then like, whatever, it's fine. I'm gonna wrap up stream here though. Thank you all so much for showing up today. If you haven't already, make sure you like the stream and sub to the channel. While you're down there, check out the description. Attached there is my Discord, my LinkedIn, and my GitHub, and also my GitHub sponsors. Join the Discord if you want to get pinged when I go live and chat with everyone else. Add me on LinkedIn and GitHub if you wish to stay up to date with what I'm doing. And support me financially on GitHub sponsors if you want to give me money, I guess. But yeah, take care y'all, take it easy. Have a wonderful rest of your day wherever you are.